Assalamualaikum warahmatullahi wabarakatuh, and hi, welcome to KLIC 2021, third Kuala Lumpur International Conference on Multi-Disciplinary Research 2021. I'm Rosita from Polytechnic Tuanku Sultanah Bahiyah at Kulim Kedah. Today I would like to present my research paper. The topic is low frequency electromagnetic field exposure on Escherichia coli growth in river water. My research topic, low frequency electromagnetic field exposure on Escherichia coli growth in river water. Introduction. Water resources pollution is often due to contamination in the consumer water. Data in 2016 and 2017 has proven that most of Malaysia river water quality was in water quality index class 2 and class 3. Currently, most areas in Malaysia are still depend on surface water as a major water supply. Thus, the pesticide problem is extending the regulator limit on bacteria in river water. It should be considered a pre-treatment method and combined with conventional disinfection technology. Okay, a little bit of introduction for low frequency electromagnetic field. Low frequency electromagnetic field is a new technique and treatment application on E. coli. According to Murshid 2010, low frequency electromagnetic field are effect on the bacterial growth in water treatment. The implementation of low frequency electromagnetic field has a potential in controlling a growth of microorganisms and regarding on a growth of E. coli and Staphylococcus areas. So, the aim of this study is to develop a new system for application of low frequency electromagnetic field on E. coli growth in river water. As we can see, this is the material and method that I'm using in this research. Okay. Figure 1. Figure 1 show geometrical orientation a low frequency electromagnetic field used for experiment with sample water flow in the horizontal column pipe. Okay, this area is water inlet and water outlet. Okay, this column is developed from perspex pipe, and the pipe was wrapped with signal column wrapped around the column pipe. The magnetic field will generate in a column pipe, and the maximum effective current was used is 6 ampere. The frequency is 50 Hz and the other parameter as shown in the table 1. The resulting of the whole inductance coil system was in the range of 2 to 10 millitesla. Okay, the diameter that has been used for pipe column is 50 mm, the length is 500 mm, and the number of turn of coil is 300 turn. The diameter of coil is 1.5 millimeter. Okay, this is the area of my study and for water sampling. Okay, the location is at Sungai Kerian. This is the Kerian River on map of Peninsular Malaysia. The study is located on Sungai Kerian at Lubuk Buntang, Kedah. The sample was collected during dry and wet seasons. Okay, the analytical analysis. Okay, from this study, I'm using the EDAC Colilert 43 2000, which is EDAC Colilert 18 method was used for E. coli tests, which have been approved by the US EPA 2002 for using in drinking water. For water sample, about 100 mm were analysed according to manufacturer instruction. From the observation, well in the yellow color indicate that the present coliform bacteria, while the well in yellow and fluorescent indicate the E. coli. MTEC member filter. The standard method is 1603 for MTEC agar numeration. This is for E. coli that was used for colons growing on the surface of the membrane filter. And 100 water sample has been collected and filtered through the membrane filter to retain the E. coli. Okay, this is the result for this monitoring. Okay, for E. coli characteristic. Okay, the biological characteristic of water sample at Sungai Krian. At Sungai Krian, the concentration of E. coli is 2,419.6 according to National Standard for Drinking Water Quality, Ministry of Health Malaysia, that reserve version December 2010. The standard were recommended that raw water of concentration of E. coli is about 500 mpm per 100 milliliter. For drinking water, the E. coli is in absent. So this is the result for E. coli characteristic. Okay, from this chart, we can see the concentration of E. coli in Sungai Krian water. Okay, the sample will take start 2020 to January 2010 to January 2020 to October 2021. Okay, as we can see, this is the figure that the result for effect of grow on removal of E. coli. Figure 1. This figure is describe or show the E. coli removal for column pipe using the flow rate 15 mm per minute. Okay, we can see the concentration or the removal, the rate of removal E. coli. Okay, the higher of removal of E. coli is by using 10 millitesla of electromagnetic field exposure. Okay, for flow rate, for pipe that flow rate in 100 mm per minute, the rate of E. coli that has been removed in 100% by using 10 millitesla is achieved at 6 contact time, 6 hours of contact time, or 6 hours of exposure. Compared to column pipe 1, the flow rate that 15 milliliter per minute, the contact hour of result that E. coli has been removed 100% is only 4 hours of contact time. Okay, so it conclude that pipe by using 50 mm per minute is higher than the removal is higher than pipe with flow rate 100 mm per minute. Okay, this figure show the removal of E. coli relationship for both column pipe at 8 millitesla of low frequency electromagnetic field exposure. Okay, we can see from the figure this is the relationship. Okay, r square, the value of r square is more than 9, more than 0.9. Okay, for the conclusion, this research is conclude that column pipe of low frequency electromagnetic field had effective in terms of the exposure time and E. coli growth when the magnetic field was increased. Result found that the low frequency electromagnetic field has significant effect on E. coli growth after 6-hour exposure, as well as remove 100% of E. coli at 8 millitesla. The application of low frequency electromagnetic field decrease the E. coli growth and efficient in possible biological effect of treated water. Actually, this situation is possibly due to the influence of magnetic flux at the various flow velocity. Okay, the growth of E. coli in coil pipe depend on the increase in intensity of magnetic field. The difference in magnetic field intensity and water flow rate might also associate with the primary reason increase of E. coli concentration. And the high magnetic field and more constant water flow effectively inhibit E. coli metabolic activity, especially those connected to their membranes, to slow down their growth. Okay, for acknowledgement, okay, the author would like to acknowledge the Ministry of Education Malaysia and Department of Polytechnic Education and Community College Education that for providing the TARGS grant for E. coli removal via low frequency electromagnetic field in riverbank filtration. Okay, this is the list of references. Okay, that's all from me. Thank you.